So today we're going to launch into Chapter 7, and basically what we're going to do is go over rules for exponents. That's going to come into play big time in our subsequent chapters, and very, very important. Right now what we're scheduled ourselves to do is to focus in on probably 1 or 2 days per lesson, because I'm not sure how much you went over this last year. I know that Mr. Mason talked about trying to do this and how you guys tended to struggle with this material. So I'm hoping that a year has passed and that your brains are stronger, and you've seen some of this with Alex too, that this won't be quite the struggle that last year it was. So we're going to talk about multiplying monomials. Okay, and today's date is 3/7. So basically what I want to do is to give you a couple definitions, and then we're going to go into what you're going to cover. We're going to do bite-sized pieces today, because there's 2 parts of when you multiply with monomials. So we're going to do the first bit, and then tomorrow, or Wednesday, we'll go on to the second bit. So first off, I want to give you a definition of the word monomials. Okay, and to touch on something that Michael just said, guys, if you're on Alex and you don't understand something, you have an explanation button. It's your obligation to click on that and to actually read through the explanation or print it out so you can have it. So there shouldn't be this, I have no idea how to do anything, because that's a prevalent attitude that is not going to be conducive to learning. So what is a monomial? Mono meaning one. Mono, one. So it's a number, a variable, or the product of a number and a variable. Okay. And right now we have this variable has non-negative integer exponents. So if we have a monomial that has negative exponents, we can't call it a monomial. If we have a monomial, looks like a monomial, and it has fraction exponents, we can't call it a monomial. Okay? So when it doesn't meet the criteria, we're going to call it, I'm going to put in parentheses, if it doesn't meet the criteria, bless you, it is called a term. Okay, so monomial only meets this definition, and let me give you something that it definitely is not. It does not involve division. So, for example, AB divided by C is not going to be a monomial, okay, because it involves dividing by C. Oh, I should say it does not involve division by a variable. Sorry, let me add that. If you have a coefficient that has a fraction in the denominator, and it's a 2, that's okay, but it's when it's a variable in the denominator, not allowed. Okay, and then we've used this word tons already, and we probably have already defined it, but let's go ahead and just put it again. What is a constant? So a constant is a monomial that is a real number. In other words, it can stand alone. So you just have a number that stands alone. Okay. Everybody good? All right, so let's talk about this guy here. The whole term, this whole thing, is called a power. So it includes that x and includes the n. Okay? Now, each of those pieces has a name. The x is called the base. And the base is the number being multiplied by itself. And the n, you guys should be familiar with, he's called an exponent. And that explains the number of times to multiply the base by itself. Okay. Now, sometimes they actually do call the exponent a power. So the exponent is AKA power. So sometimes you'll hear people say, oh, that's x to the nth power. That's 2 to the 5th power. So you'll hear that expression. Okay. So let's use a number example. What if we have 3 to the 4th power? Well, basically all powers is a fancy way and a shortcut way of showing a multiplication problem. It says you're going to multiply 3 by itself, by itself, by itself. How did I know when to stop? Well, 1, 2, 3, 4. It's got to match the exponent, okay? Now, a lot of people start memorizing these little ones because you see them so often, all right? And then the value is going to be just what the product is. So we end up with 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. So when I'm multiplying and the bases are the same, so now I'm going to take and I'm going to use x to the 5th power. Actually, let's do it with numbers. Let's do 4 to the 5th power, and I want to multiply it by 4 squared. Basically, I can expand out what this problem looks like. Well, in the first one, it says you have 1, 2, 3, 4, 5 4s being multiplied together. The second one says you've got 2 4s being multiplied together. So how many 4s did I have altogether getting multiplied by each other? Okay, I have 7. So looking at your original problem, do you see a shortcut way of getting that answer of 4 to the 7th without having to expand it out? What do you see? Yeah. So what it looks like is if I take my base and I add my exponents, I got my answer. And basically what we've just done is talk about the product of powers rules. So the rule says when I have a power and I multiply it by the same base, but it may have a different power, all I'm going to do is keep the base the same. The base isn't going to change. 4 didn't change into anything. But all I'm going to do is take my 2 exponents and add them together. So in words, when multiplying 2 bases that are the same, and it's not even limited to 2, it's as many as you want. You're going to add the exponents. Okay? Now, when bases are the same, you'll often hear the term like bases. So I'm going to write that in here. So A and A are considered like bases. So when you're multiplying like bases, so that doesn't limit it to 2, that means they're the same, you're going to add the exponents. Okay? So let's do a couple of examples and then, yes?
So I know it would be like A and then MN.
No,
Or just be A.
MN is multiplying. You have to add them. So you write the base once, the base never changes. That, for some reason, when kids see numerical bases, they want to multiply them. I get a lot of times the answer is 16 to the 7th power, because they multiply the base 4 times the base 4. That's not what this rule says. The rule says the 4 stays 4. Because I didn't change to 16s when I had 4 times 4 times 4 times 4 times 4 times 4 times 4. They all stayed 4s. So I keep the 4 as the base. What changes is how many 4s I had, and I can do it quickly by just adding them together. Okay? So let's give you an example of what this would look like, and the directions are just going to say simplify. So we have 6n cubed times 2n to the 7th. So I'm going to rearrange this problem because mathematically it would look like this. 6 times n times n times n times 2 times n, 2, 3, 4, 5, 6, 7. Okay? So 2 of those things are not like the others. Which are the 2 that kind of stick out like sore thumbs?
The 6 and the 2.
Yeah, those coefficients. So I'm going to use commutative property of multiplication, and I'm going to rearrange and put them side by side. Okay? And then that means I'm going to gather up all those n's. So I had 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And then I just do the math. 6 times 2 is 12. And then I count out my n's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what this property is telling us, but let's show how easy it is when I do the rule. As soon as I see this problem, I quickly grab my coefficients, and I know I'm going to multiply them together. And then I'm going to take my bases, and I'm going to take the exponents, and I'm going to add them together. So I end up with 12n to the 10th. Okay? So that's what you're going to be practicing tonight, is multiplying monomials. You're going to multiply the coefficients if there are any, because they belong together, and then you're going to add the exponents on the variables. Okay? And by the way, on Wednesday, we'll get into harder versions of this, so just be forewarned.